Service operations. In the first portion of this chapter, we will focus on the operations management of a service business. We will discuss the meaning of the customer experience and the use of technology. We will also look at the strategic vision for services. A pure service produces no goods, but in general, all businesses are a combination of goods producing and service delivery. Note that the customer is an active part of the service process. Here we see examples of service businesses. Business services include banking and financial services. Trade services include retail, repair, and maintenance. Infrastructure services include communication and transportation. Other examples include social services like restaurants, recreational activities, healthcare, and childcare. Different governmental agencies and educational institutions are part of public administration. Redefining operations management for services simply changes the output from a product to a service. Structurally, we transform labor into a service. Here, production is the creation of the service, while operations management controls the activities that transform inputs into services. Comparing goods and services, we see that products are tangible, while services are intangible. This chart lists the attributes of goods and services. Note the lack of service inventory and the difficulty when measuring service quality. The location is more important for services. Here's an example where goods and services complement each other. The wine or product purchased from a wine shop adds to the dining experience or service at a restaurant. This graph shows a number of examples where companies provide a mix of goods and services. We see that most goods producers provide services and that most service producers require goods as part of the service delivered. Can you think of a product that includes no services? Here we see the connection between a number of services in the U.S. economy. Manufacturing requires financial services, infrastructure, and business services to operate. Government services support infrastructure, distribution, and business services. Finally, the customer requires personal services, governmental services, and distribution services. Think about the behind-the-scenes processes required for the last product you purchased. Note how the various services were involved with getting that item to you. For the U.S. economy, we have seen the growth of services and the decline in agriculture and manufacturing. The U.S. is often referred to now as a service economy. This graph suggests that this is true. Productivity is measured as the output divided by the input. In other words, how much labor is provided for a given set of service activities. The service package includes all of the elements necessary to provide a given service. First, a facility must exist where the service is provided. Supporting goods must be available, like packaging at a shipping counter. Information is often key to the service. Consider the tracking data provided by FedEx. Then we get to the actual explicit service being provided. In this case, the movement of a package to its destination. Finally, implicit services are included that support the overall customer experience. The design of service systems can come in many forms. Some are modeled after the systems used to produce physical goods, while others are unique to the service industry. The production line approach is used when multiple steps are required to deliver the service. The second design includes the customer in the process as a participant. Think of self-serve activities in fast food restaurants. The third manages the customer contact, while the last uses information to empower the service employee and add to the customer experience. Elements of the service design are shown here and are broken down into structural and managerial elements. Structural elements refer to the physical realities of service delivery, while the managerial elements are associated with the process of delivering the service. This includes strategies and metrics. The service vision of an organization includes the various strategies used for service delivery. For Southwest Airlines, this includes their standardized fleet of aircraft, employee empowerment, frequent scheduling, and open seating assignment. This table shows additional detail of the strategic service vision for Southwest Airlines. Service delivery focuses on the customer cabin crew interaction and the use of a single model of aircraft. Operationally, the goal is to turn aircraft around quickly to keep them flying. This is aided by their open seating system for passengers. Their service concept is to compete with car and bus travel by serving smaller regional airports with frequent flights of shorter duration. Their target market segment includes regional business travelers and families. To define the vision of the service delivery system, we define the key features, capacity, quality standards, and differentiation. What methods will we use to provide the service at what level? Our service operating strategy considers operations, financing, marketing, and staffing. What areas are our key focus? How will we measure our performance and our success? What is our competitive stance? Our service concept includes the elements to be provided to customers, including customer perception. Based on these criteria, how will service delivery be configured and delivered? To identify our target market, we identify common characteristics, including demographics, and prioritize the different segments. How is each segment best served? How well are these customer needs being met today? The terminology and metrics used when delivering service parallel those when manufacturing a physical product. Since labor usually makes up a large portion of service delivery cost, this is a particular focus. The service measures are very similar to the metrics used for a physical product. Various tools are used to analyze a service system. The top 4 tools are common to the production of physical goods. The Service Blueprint is a new tool that details the customer interaction. The Service Blueprint maps out the interaction with the customer. 3 levels are defined with different issues and opportunities. Here's an example of a service blueprint for SpeedyLube. The blueprint uses standard process flow symbols. Ovals are activities while diamonds are decision points. We start at the upper left when the customer arrives for service and finish at the upper right when the customer departs. Note the 3 levels with level 1 associated with the customer. The middle level defines those parts of the service organization that interact with the customer, while level 3 is in the back room. Level 3 is necessary for completion of the service but is not part of the customer interaction. The red circles represent opportunities to upsell or fail. Particular attention must be paid to these points in the process. Another example of service delivery looks at the Department of Motor Vehicles. In Illinois, this process is handled by the Secretary of State Driver Services. Looking at this example, the issue is one of work allocation. This service blueprint uses different symbols to represent each step in the process. A legend is shown at the right. The upper left shows the activity number, while the bottom number represents the cycle time of that activity. The number at the right shows the capacity of each station. Looking at the data presented, which station is the bottleneck? What is the system cycle time? How much labor is used, and what is the efficiency of the current system? Given the answers to these equations, what suggestions do you have to increase capacity? Answering these questions, we see that Station 3 is the bottleneck, since it has the longest cycle time at 60 seconds. Efficiency is the ratio of value-added time to the amount of time workers spend on the process. We assume that each station is staffed by 1 worker. Since the system cycle time is 60 seconds, we know that 1 unit of service is completed every 60 seconds. We calculated the total value-added content by adding the cycle time at each workstation for a total of 195 seconds. Given this information, we have an efficiency of 54%. Now we consider steps to improve system capacity. First, we consider doubling the entire process, adding 6 new stations in parallel. This doubles our capacity but maintains an efficiency of 54%. This is a good first step, but we can do better. Now we consider adding a second violations workstation to address the bottleneck. Doing so reduces the overall system cycle time from 60 seconds to 40 seconds, with a 50% increase in capacity. All this while only adding one person and ending with an efficiency of just under 70%. This is a good example of improving the system with minimal added cost. Process redesign takes this process one step further. Redesign of the service process starts from scratch and looks at the overall process, questioning all aspects of the current process. This is often called a greenfield evaluation. You are looking at the process, knowing what you know now, but with a fresh set of eyes. Particular attention is paid to those activities that cross boundaries within the organization. Since services often include intangible content, quality is more difficult to measure. Matching employee and customer perceptions is key to success. Services include routine activity and exception handling. An organization is often judged more on its ability to handle issues and variation. This is the exception process. Many service quality attributes are shown here. Note that some align with those of product quality, while others, especially the intangibles, are unique to services. Services are enabled by information technology. Often, information is the service provided to customers. Information technology provides visibility, as in the tracking capability at FedEx. IT also helps you understand customer patterns, as in the park forecasts at Disney. Pricing may also be managed by demand, as in airline and hotel pricing management. IT capabilities can provide a competitive advantage, especially when real-time systems are available. Reservation systems and point-of-sale systems are essential for many service businesses. Offline systems provide the analytical tools to manage the business operationally and over time. IT also provides growth opportunities for a service business. Innovations, along with adapting to changing demographics, also provide opportunities for growth. As a reminder, here is a list of the 10 decisions of operations management and where they are found in the text. These decisions apply to the service business, but in varying ways. Looking back at our original definition of operations management from the first chapter, we see how each may be applied to a service business. Here we look at the elements of the supply chain and see that this concept applies to a service business once we remove manufacturing operations. Service providers use suppliers, distributors, and retailers. The delivery process is supported by management, engineering, marketing, accounting, and information systems. The degree to which each of these elements is utilized for the service is a function of the type and scope of the offering. Here we see a depiction of various functions that are part of the product supply chain. Note that while some manufacturing functions are not included, many functions are similar for the service supply chain. Here we see a variety of service types and associated businesses. All use some form of operations management to be successful. Now we move to a discussion on waiting lines, or queues. The goal of this unit is to understand and evaluate the characteristics of arrivals, waiting lines or queues, and service systems. This discussion will include theory and costs associated with waiting. Queuing theory is the study of waiting lines and applies to both manufacturing and services. Here are some situations where waiting in line is common. The table lists the situation, who or what is in line, and the associated service process. One that I think is interesting is the example of the computer system. Computers, especially those with a single processor, only do one thing at a time. Since multiple programs may be running at the same time, they must wait in line and take their turn to be executed. Can you think of an example when you have waited in line that is not on the list? Waiting line systems typically include arrivals or inputs to the system, the waiting line itself, and then the facility where the service is provided. The definition of these characteristics will vary based on the type of arrivals, how the queues are designed, and the services provided. This process diagram further defines the three parts of the waiting line. In this case, a car wash waiting line starts with the arrival of dirty cars. The number and time distribution of arrivals must be analyzed to understand customer demand. Next, the service system includes the queue and the service facility or car wash. The design of the queue will be based upon demand characteristics, the service process, and available space. Finally, customers exit the system by driving away in their clean cars. For the car wash, do you believe the number of possible customers is finite or infinite? Historical demand data, along with a review of local demographics, might give you good estimates. For the arrivals, is the work scheduled or random? Random arrivals are typically modeled by a Poisson distribution. Finally, will arrivals stay in line in an orderly fashion? Balking customers might see a long line and simply drive past the car wash. Reneging customers get in line but grow tired of waiting and leave. To analyze customer demand, using a Poisson distribution, this equation is used. P of x is the probability of a certain number of x arrivals, which is the number of arrivals per unit of time. Lambda is the average arrival rate, and e is the base of the natural logarithm. Don't be intimidated by this equation. If you have access to Microsoft Excel, use the Poisson.dist function to simplify your work. Here are two examples of a Poisson distribution for x values from 0 to 10, given lambda values of 2 and 4. For the first graph, the peak of the distribution is near 2, while the peak is near 4 for the second graph. The equation is repeated here. Waiting line characteristics include the length, discipline, and other priority rules. For queue discipline, first in, first out, or FIFO, is the most common. FIFO means that the first person in line gets served first. Few people like it when someone who arrives after them gets served ahead of them. Queuing designs are concerned with the number of servers and the number of phases. The number of servers reflects how many service stations are available in parallel. The number of phases counts the number of steps required in the service process. For example, if a bank has a single line feeding multiple windows, that would be a multiple server, single phase queuing system. Additionally, the service is defined by the amount of time required to deliver the service. At an automated car wash, the times are constant, while service at a bank may vary based on the type of customer transaction requested. These flow diagrams show different queuing system designs. A dentist's office with only one dentist would be a single server, single phase system. At this McDonald's, the service process has two steps, or phases. The first window takes your order, while the second window gives you your food. This would be a single server, multi-phase system. At this bank, we have a single line feeding multiple teller windows. Each teller can perform all services, so there are no additional steps required. This would be a multi-server, single-phase system. This process flow shows a multi-server, multi-phase system for a common college registration process. There is a single queue feeding two parallel sets of processes, or phases. To measure the performance of the queue, there are a number of common metrics used. The time in queue and the queue length are the most common. We may also measure the average time a customer spends in the overall system, including the wait time and the service time. We can look at the number of customers in the overall system. Based on this data, service managers can calculate the probability that the service facility will be idle, the utilization factor, and the probability of a certain number of customers being in the system. These calculated results can be used to plan staffing and capacity decisions. We can graph the service system costs and find the optimal service level based on cost. The cost of providing the service goes up as we increase the service level. Conversely, the cost of waiting goes down as we increase the service level. This is because with increased service capacity, fewer people have to wait. Summing the service and waiting costs, we get a total expected cost. The graph of the total expected cost has a vertex which shows the lowest cost. the service level at the vertex would result in the lowest overall cost.